All right. Problem number says rewrite this as a fraction involving only sign. All right, so we're starting with cotangent over secant. Okay. What do we know about cotangent? Well, it's the reciprocal of tangent. What else do we know about it? X over y. What else do we know about it? Still waiting to hear the one I want to hear. All those are right. Those are all right. Cosine over sine. So I'm going to think of this as cosine over sine. What is secant? Reciprocal of cosine. So 1 over cosine. So we have cosine over sine divided by 1 over cosine. If I write this out longhand, it's this divided by this, which is cosine over sine times cosine over 1, which is cosine squared over sine. Now, why is my little heart going here? Because cosine squared is 1. 1 minus sine squared, that's exactly right. So your job, nothing here cancels, you won't be canceling, you're being crazy. Your job was to rewrite that expression in terms of only sine. And we did that. Okay? All right. I want to take a look at your quizzes and get that fixed. So here come your quizzes. We're going to get and some homework and all that stuff here. Yes, keep your quiz.
I thought it was greater than or equal to and less than. Oh, that's so.
I didn't know.
What did it go? I got
The purpose of a quiz
So,
is to kind of wake yourself up a little bit. In case you think you know more than you do. All right, just about down here. We're gonna look at these quizzes. Problem because
That makes no sense.
all right, I think I got everything. All right, so let's look at the quiz.
Pardon this interruption. At this time, any student who is part of the math choir should report to the Launch Activity Center. Thank you.
Go choir, go. Let's take a look at our quizzes.
Wait, so there were 4 answers. Since when are there ever 4?
All right, here we go.
I mean, yeah, but like, this is like, that makes sense.
All right, here are the directions. Here's the problem. What do we do? What do we do? Factor out. Well, can't factor out until I move it over. So I'm gonna move that cosine over. And then I'm gonna factor it out. So is everyone with me to this point? 170 equals 0. Go factors. And then we're gonna figure out where is the cosine 0. Now remember, you can always draw your unit circle. Where is the cosine, which is x, 0? Where is the sine 1/2? There we go. Now, if you missed that problem, and some of you did, you got it? Okay? All right. Number 2 is an inequality. But the directions are the same. All right, so what did you do here with this one? Get it all on the same side, or at least get all the signs together here. So 2 sine less than 1. Does that look okay? Which means sine is less than 1/2. So again, feel free to use a unit circle. Where is the sine, which is y, 1/2? We just did that. Isn't it pi over 6 and 5 pi over 6? So if this had been an equals, the answer would be pi over 6 and 5 pi over 6. But it's not, it's a less than. So we need the sine to be less than 1/2. So we're talking about all that right there. Now, how do we write that answer? Remember, we're starting at 0. So, we'll start at 0 and go to pi over 6. And then we'll pick up again at 5 pi over 6. And go to 2 pi. Everybody okay with that? Okay. All right. And the last one, which was a disaster for some of you. So let's pay real close attention, make sure we are following what's happening. So we have 5 tan squared, by the way, directions are the same. So those of you that put negative answers down, now I'm not saying there couldn't be negative answers, but not in this case. Our answers have to be between 0 and 2 pi. will the tangent be positive or negative? Everywhere. So somewhere, and I don't know where, it's not one of my special angles, somewhere in all of these quadrants, so here and here and here and here, there's an angle that has a tangent at either positive the square root of 2/5 or negative the square root of 2/5. Okay? Now, the good news is all of these angles are the same. It's like having a pi over 6 in every quadrant, only it's something I don't know in every quadrant. So I just need to figure out what that angle is. So how do I find that out? First of all, I make sure I'm in radians. And then, second tangent, the square root of 2/5. And I got 0.564. Okay, so some of you didn't even have the right number down. So type that in right now. If you missed it, type it in right now and make sure you can get 0.564. All of these are 0.564. So, in quadrant 1, would you agree that the answer is 0.564? In quadrant 1, that is the quadrant 1 angle. Now, I gotta put that 0.564 into quadrant 2. When I put it into quadrant 2, it's this angle, right here, this dot, right here, this angle. How do I calculate that? Pi minus, exactly. So pi minus that. So that one is 2.578. Now I gotta get a 0.564 angle in quadrant 3. How will I get that one? This is all the way around here. This dot right here, this angle right here. How do I get all the way around here? What would that be? 0.564 plus 5. So 3.706. And finally, my last one, my 0.564 angle in quadrant 4. How would I find that one? 2 pi minus, that's exactly right. So 5.71. Not very many of you got that one right. So we need to make sure we get this now. Anytime we square root, it's plus or minus. Don't forget, some of you forgot that, and that's why you didn't get enough answers. Make sure that your answers fit the range that you're given. No plus or minus, pi k, all that, none of that. You okay with that? After break, we're gonna try this again. We have a little bit bigger quiz, but we gotta know how to solve our equations, guys. Yeah. Okay? All right, let's go back and talk about any more of the circuit training we started yesterday. I think we got most of it done, but I don't know that we got it all done. And I don't remember where we stopped. keep it. I want you to learn from it. I want to do, and I don't know, I did them all. For me, this is my problem 19. I don't know if you made it that far or if I need to write on that. But I want to solve this equation right here. And I want to find the exact, for me, this is number 20, the exact cosine pi over 12. I want to do these two problems. All right, here we go. We're going to solve that equation right there. Anybody have an idea? Okay, we talked about this the other day. We had an equation that looked just like this. Really?
Is it the sine of 2x sine?
Yeah, well, I'm not gonna do that, I'm gonna go straight to my identity. If I forget my identity, I can always do that. But you can't solve the equation with a 2x and an x. It's not doable. I mean, without your calculator, it's not doable. So, we're gonna take this sine 2x and change it into what sine 2x is. What is sine 2x? Two sine x cosine x, that's exactly right. So now, this looks exactly like the quiz question. What do we do to solve this? Get the cosine over. And then we'll factor. And then I'm not gonna finish it because isn't that exactly what our quiz question was? It's exactly the same problem. Looked different in the beginning, but that is your quiz question. Okay. Find the exact cosine of pi over 12. What do I do here? So think of your unit circle and find two that either add up to 1/12 or subtract to 1/12. So, can you think of two from our unit circle? Any two on the whole unit circle, any quadrants that would either add or subtract to give me pi over 12. Parker says pi over 3 minus pi over 4. Let's do a quick check. 1/3 minus 1/4. I think he's right. An option. So now we've got the cosine of alpha minus beta. Cosine x minus y. Cosine angle minus angle. What does that formula say, that identity? Cosine of the first, cosine of the second, plus sine of the first, sine of the second. All right, here we go. Pi over 3, cosine is 1/2, and sine is your 3/2. Pi over 4, they'll go through 2/2. So it looks like we're gonna get the square root of 2 plus the square root of 6 all over 4. That okay? All right. This is next to last note, and then one more set of notes after this one. Then we start reviewing for the biggest day of our lives, May 12th. Okay, so we don't have much time, we're gonna just get a quick introduction here. So we'll finish this up, obviously, after break. But here is something brand new. We haven't done very many things that were totally brand new, but I think this is one of them. At this point of your life, when someone has given you an ordered pair, like 2, 3, you have plotted it by counting over 2 and up 3. Agreed? This is called a rectangular, like actual graph paper. This is called a rectangular system. These are rectangular coordinates. Because the system is based on over and up, right? Horizontal and vertical. Today we're going to talk about a new way of graphing in a different kind of system, and it's called the polar system. So we're going to have polar coordinates. Now, with rectangular coordinates, you have an x and a y. So x-axis, that's your y-axis. Okay. With polar coordinates, we have an r and a theta. So polar coordinates are a distance. You can think of that as radius, but you can think of it as radius, but it's really not radius, but it's a distance, okay? And an angle. So your coordinate system looks like this. It's a circular system. So if I wanted to plot the point 2 comma pi over 4, let's say, that means I count out 2 units, that's my distance, and then I go an angle of pi over 4. That would be pi over 4 right there. So that point would be plotted right there. Now, the biggest difference between rectangular coordinates and polar coordinates is, if I said to you, what are the coordinates of that point right there? If I said to you, Parker Scott, what are the coordinates of that point? You would say 2 comma 3. And if I walked out in the hall and asked some random person, he would say 2 comma 3. And if I asked somebody in China, he would say 2 comma 3. Rectangular coordinates are unique. There is only one way to name that point. It is 2 comma 3. Polar coordinates aren't that way. Certainly, one way to name that point is 2 comma pi over 4, but that point can be named in other ways. Can anybody think of another way of naming that same point?
2 comma 9 pi over 4.
2 comma 9 pi over 4. Wait a minute, what did Leo do? He went all the way around and came back to the same point? Wouldn't that be plotted in that same place? Can you think of another one? 2 comma negative 7 pi over 4. So instead of, counting out 2, but instead of going in the positive direction, we go in the negative direction. 7 pi over 4. It gets even crazier. Obviously, could we come up with more than this? Yes, there are infinitely many, but it gets even crazier. This point right here, could be called -2, 5 pi over 4. This is why I hesitated to let you call this a radius, because r can be negative. Now, what in the world does that mean? This was the original point, and I'm telling you, this is another way to name it. Does anybody see what's going on there? Can you think about that at all? So that negative is really like the opposite. So if we are at 5 pi over 4, we would be right here, right? But because it's negative, r is negative, it goes to the opposite side of the circle. And where would that put me then? If I went to the opposite side of the circle, wouldn't I be at pi over 4? So if your r is, okay, if your theta is negative, that just means you go this way. If your r is negative, that means you go to the opposite side of the circle. So, let's practice one. What if we had the point 3, 2 pi over 3? If I made r negative, what angle would I have to have if I made r negative? 5 pi over 3. How did Quinn do that? Exactly. The opposite side of the circle is how much? Pi radians? So he said, I'm just going to add pi to it. These 2 points are exactly the same. They would be plotted in exactly the same place. I know, it's a little mind-blowing. Let's look at example 1. Plot and label in the grid above. Plot and label in the grid above. Now watch your scale. So go ahead, you guys do it. We'll talk about checking your answer. How do you feel about my points? Do they look about like where yours are? Really good? All right, let's try number 2. Same exact thing. See if you can do number 2. you get all those points to the very same place? Right? And that's what we talked about, the polar coordinates can be, or points can be identified in the polar plane in many, many, many different ways. All right, example 3, quickly, it's the last one. Example 3. Plot the point with that coordinate, okay, you can do that. And then write polar coordinates for that same point in other ways. So go ahead and plot it. So it would be like over here. And give me some names, some other ways of naming that point. So 3 comma negative 7 pi over 6.
-3, -5 or 6.
Negative 3 negative pi over 6. Let's get one more. Negative 3 7 pi over 6. I don't think it's 7 pi over 6. 11. Does that make more sense? 11 pi over 6? All right, can we get one more? Can we get one, let's see. We have a positive, negative. Let's give it a positive, positive. So positive 3 comma
17 pi over 6.
17 pi over 6. Everybody okay with that? All right, good. We're gonna pause there. And next time we'll do a little bit more of this and some recapping and reviewing, because we will be having another quiz sometime that